Welcome back, everybody. The goal of this session is to be able to have an expansive discussion talking about how we can bring new technologies to scale. The structure for the discussion, we're going to have three interventions at the start to lay out some ideas to get us going, but very much want all the people here in the room to be involved. So if you have something to say, if you're sitting on the table, just take your name badge and turn it so that I can see you have something to say and I can come to you. If you're in the audience, please just raise your hand. There is a rotating mic that can come to you. Please keep your interventions short. They can be statements, they can also be questions, but as long as you are able to keep it in a minute or two, we can have a good interactive discussion. And with that, I think it's easiest for me to tap the experts I have on the panel to give you the fodder for the discussion over the next 90 minutes. And so I'll introduce them. Each of them will speak for a short time, and then we can, nobody has the answer to all the problems that we want, but hopefully with this discussion we can come up with some answers, and what you say will contribute towards the discussions that will happen tomorrow among the ministers. So what you say matters. With me on the panel, I'm delighted to say I have Evelyn Wong, who's the director of ARPA-E in the US as part of the Department of Energy, and funds a lot of the advanced technologies over the years that we have benefited from. Pinakin Chobal, who's the Chief Technology Officer at ArcelorMittal, one of the biggest steel companies in the world, and Kojo Ako-Asare, who's the Managing Director of Decarbonization Partners and funds many of the clean energy technologies that we need. Evelyn, maybe we start with you first.
Great. Well, good morning, everyone, and thank you, Akshat, for that great introduction. It's really a pleasure to be here today alongside with Pinakin, Kojo, and Akshat to speak about the flow of new technologies. Truly, we are at a pivotal moment. We've heard that today already, where the choices we make in energy technology will shape our planet's future. And this is why at ARPA-E, we believe that supporting the high-risk, high-potential energy technologies is not just an option, but a necessity to reaching net zero. So ARPA-E is the US Department of Energy's, is often referred to as the moonshot factory, the innovation arm of the Department of Energy. And so we're tasked to support the early stage research and development of energy technologies that can completely change the way we generate, store, and use energy. And when I mean early stage, about 50% of the projects that we support are led by universities. And our agency provides the necessary funding and the support to de-risk the innovative technologies to the point where the private sector will invest and ultimately commercialize the technologies and deploy them at scale. Another key differentiator of ARPA-E is that we have a team of experts that work alongside our project teams to not only review the projects, but to offer solution-driven feedback. And that includes support towards commercialization. And this is one of ARPA-E's defining characteristics. We don't just provide funding, but we help projects find a path to market. And our portfolio reflects the success of this model. Since 2009, when we were stood up, we have provided about $3.7 billion in R&D funding for over about 1,500 projects. This has led to 150 new startups and close to about $12 billion of private sector follow-on funding. And the technologies that ARPA-E has supported has had great influence in a range of industries, ranging from electrification to power generation and storage, as well as industrial decarbonization. And the expansive nature of our research is derived from our philosophy that diversification of technologies is essential to our journey to reach net zero. Because we recognize there are still gaps and limits to meet our nation and the global energy targets. And for that reason, we are always looking for technological white spaces, areas that we need to explore to truly enable these disruptive, transformational energy projects. And so from my own experience as a professor at MIT prior to my role here, as well as currently what I see as director of ARPA-E, we recognize how difficult it is to truly commercialize energy technologies. Innovating impactful market-ready solutions goes well beyond that proof of concept, as we've heard already today. And innovators really have to consider the next steps, which includes the reliability of the technology, looking at design for manufacture, supply chains, market conditions, and competitors. And recognizing the challenges that these innovators face in commercializing, our agency actually started a new recent program since 2019 called Scale Up. And we heard about already the valleys of death. And we like to think about it in the context of mountains of opportunity. And that we're trying to bridge one of these gaps to be able to work towards the commercialization goals. And what I thought I'd do briefly is share with you two examples of technologies that we've supported through this path from proof of concept to that towards commercialization via our Scale Up program. The first company that I'd like to share is a company called Sila Nano. In fact, we started supporting the technology when it was a spin-out, just fresh out from Georgia Tech. And what Sila is doing is they're developing a silicon-based anode material as a drop-in solution for lithium-ion batteries. And what this can achieve is 20 to 30% higher energy density than state-of-the-art. And this can certainly accelerate the adoption of electric vehicles. And so with our funding, they've been able to not only show that these kinds of silicon-based anodes can in fact improve performance, but with Scale Up, they can actually find a path towards commercialization by now producing this anode material 1,000x more than they were able to do at the early stages. But beyond that, they've created partnerships with, for example, automotive manufacturers such as Mercedes and others. They've received $800 million in private follow-on funding. And most recently, with the legislation with the US, that in fact with the bipartisan infrastructure law, they've been able to now receive funding from the US Department of Energy, Office of Manufacturing and Energy Supply Chains, that selected Sila to now receive $100 million to build out a 600,000 square foot factory to further scale and commercialize their technology, ultimately to be deployed for hundreds of thousands of electric vehicles. So that's just one example, and I thought I'd give you just one other short example, which is another very different technology from a company now called LongPath Technologies. When we started supporting them, in fact, it was in a lab at the University of Colorado Boulder. And what LongPath is doing is they have developed a dual frequency comb spectrometer to identify parts per billion sensitivity for methane emissions. And in fact, what they can do is now detect leaks all across the natural gas supply chain by continuously monitoring real time across 30 plus square kilometers. And what we have been able to support through this journey is getting it from this lab optical setup to now a proof of concept, and also now with customers being able to show a solar-powered tower that can now be deployed with about 20 customers in their pipeline. But beyond that, of course, they've also now garnered a lot of venture funding. And now recently, it just was announced with the support of the Department of Energy's Loan Programs Office, they received an $189 million finance support to be able to now deploy at scale. And one of the key parallels in these two examples that I shared, in fact, is related to the success and importance of collaboration. And while we at ARPA-E will continue to support the early stage research, we also believe that prioritizing research collaboration across all sectors, including the government, the policymakers, corporations, nonprofits, and academia, is essential to this journey to deploy. Because we know that getting to net zero will take not only a diversity of technologies, but a diversity of collaborative approaches. And this mentality aligns very much with the rest of our US Department of Energy, where we believe that together we are focused on urgently propelling towards advancing the adoption of clean energy technologies that can transform the world at this very critical moment. And in supporting these innovative technologies, we don't pick winners and losers. We think about creating the playing field and giving policymakers, showing them what's possible and what's truly needed to reach and accelerate the path to net zero. So in conclusion, I'd say that the path to a sustainable energy future is paved with innovation, collaboration, and also the willingness to embrace risk. And at ARPA-E, we are committed to this journey, tackling challenges and accepting that risk is essential in revitalizing global energy innovation. So together, with a concerted effort and a shared vision, we can build this net zero world for our future generations. Thank you.
Thank you. One thing that is necessary for these innovations to work at scale is to have big industries be partners. Pinnakin, you lead the technology office for ArcelorMittal, and as a large shareholder-owned company, you have, of course, a product to produce, customers to make happy, and shareholders to please, and yet you also have to now tackle the challenges that society faces in decarbonization. So would love to have your remarks on the topic.
Thank you, Akshat, and it's a pleasure to be here. Representing ArcelorMittal, we are one of the largest steel producers and also iron ore producers in the world, and probably the most global, which provides us with a very unique and global outlook in terms of what are the challenges facing us in the steel industry to decarbonize. So I'd like to just share some thoughts that we have. First of all, traditional steel making, depending on whether you are using coal or natural gas, we generate about 1 ton to 2 tons of CO2 per ton of steel. That's given. If you go to electric steel making, we can drop it down to maybe 0.5 to 0.6 tons of CO2 per ton of steel, depending on the carbon footprint of the electrical power that you have. So the question may come, why don't we all start going towards electric steel making, which is largely using recycled scrap? By our estimates, even in 2050, we will still need to use about 50% of the steel production technologies that are based on iron ore, just to meet the demands of the steel in the world. And even by the turn of the century, that number may drop to, say, about 30-40%. So that's one thing. Second is that there are very high quality, value-added steel that's necessary, which will need what we call clean iron units. And clean iron units generally have to come from iron ore. So that's a big challenge for us. It means that no matter what we do, we still need to have technologies that will produce steel starting from iron ore. Now today, globally in the steel industry, there are many technologies that are being tested out and even are at scale: hydrogen-based steel making, large-scale use of biomass, carbon capture and storage, and even direct electrolysis of iron ore. The challenge for us is that we need to scale them up. and we need to scale them up quickly. Now, the second aspect, and we talked and we heard a lot about that, is cost, capital cost and operating cost. So this is not our estimate. Mission Possible has made an estimate that if the entire steel industry was to transfer or transform to electric steel making, you're talking of about 5 to 6 trillion US dollars. 2/3 of that is going to be for infrastructure which is outside the steel industry, and largely electricity. A rough estimate is that we are going to need something like 1.5 to 2 terawatt capacity of electricity for this transformation. And this is a huge amount. I was told there is something in the order of about 50 to 60% of the total renewable energy that is there today in the marketplace. Other part is operating cost, and there was again some talk about that. Our estimates are that with the existing clean steel technologies, we can go to produce clean steel compared to, I think somebody used the word brown steel, but I don't like that word. Our premium is 75%. Even by 2050, where infrastructure will be available, we are still going to be somewhere in the range of 30 to 40% premium. And that is a huge, huge issue that has to be tackled. So the question in front of us is, what do we do? And I'll just briefly mention it, and maybe we can go into more details in the discussion. So first of all, we need to be supported at scale. You heard Director of ARPA-E talk about it. So just as in solar, where we saw the cost drop dramatically when scale-up occurred, we need the same thing to happen for technologies for steel making. But we need that to happen much faster. We can't wait for 30 years for that to happen. It has to happen much faster. This is one. Secondly, policy needs to change. And we talked and we heard a lot about that today also. So policy needs to change, but it needs to evolve fast and, more importantly, be implemented fast. To be very honest, today policy is coming slowly and implementation is also coming slowly. And what is most important is that these policies should ensure that clean steel making becomes as competitive as steel making from traditional technologies, so that the steel industry can remain vibrant and be successful globally. I don't mean region by region, but globally. And the third point I'd like to make, and we can get into some examples on which we are working, is cross-sectorial collaboration. I think that this is probably one of the most important directions that we have to take. Cross-sectorial collaboration along with industries that are also having difficult time abating CO2 or also contributing to the greenhouse gas emissions. And these are areas such as green power generation, areas such as co-use of byproducts from each other. So as an example, in traditional steel making, blast furnace slag is a big contributor to the CO2 reduction in cement manufacture. If blast furnace iron making decreases, what are we going to do to replace that amount of blast furnace slag? And the third part also, which I'd like to kind of mention, and we can go into it in more detail, is collaboration with other industries so that power to chemicals, gases to chemicals becomes an integral part of the steel making value chain. So with that, I'd like to stop. And hopefully some of these thoughts will generate more discussion in these.
Yes, thank you very much. And Kojo, in this sort of ecosystem that needs to be created, finance has to play a key part. Could you talk through the work that you do with decarbonization partners, and where do you see current opportunities that you're pursuing, but also bottlenecks where you would prefer to go, but currently there aren't enough?
Yes, thank you. Good morning. It's lovely to be here with all of you here at the Energy Innovation Forum. My name is Kojo Kuwasari. I'm a managing director with Decarbonization Partners. For those of you who do not know, Decarbonization Partners, we're a joint venture between BlackRock and Temasek, both of which have been very active in renewables for the past decade. Actually, through their experiences over the past decade, they've recognized that there is a growing opportunity to invest at the growth stage of a lot of these climate businesses, and they came together and created the Decarbonization Partners platforms. So at Decarbonization Partners, we focus on companies that we believe will benefit from two accelerating macro trends: the declining cost of advanced computing and advances in material science. We look to invest in companies that have reached an inflection point and are preparing to scale. These companies have typically retired the binary R&D risk. They've demonstrated market demand for their products and successfully completed an operational pilot. It's helpful to provide a little context on kind of where I am and where we are as an organization. So I entered the space in 2011 in the wake of Clean Tech 1.0. And it's, at the time, it feels funny to say this, but people were skeptical about the technology risk in solar and wind. It's really funny to say in 2023. The common refrain back then was the excessive land use of solar and wind, and that in comparison to fission or gas turbines, it was too large of an obstacle. In hindsight, and life is what it is, it's interesting that we clearly ignored the basic lessons of industrialization, which is Wright's law says for every cumulative doubling of units produced, costs will fall by a constant percentage, which generally is around 20%. So today, there's no question regarding utility scale solar and wind. We see that as commonplace, as we did back then for a gas turbine power generation. I'd like to share some numbers to kind of put things in perspective. So onshore wind in 2014 was $113 a megawatt hour. Today, it's approximately $30 a megawatt hour. Solar in 2014 was $145 a megawatt hour, and today is around $40 a megawatt hour. And my favorite, and this is in line with Evelyn's comments, the pack pricing for a lithium-ion battery in 2010 was $1,300 a kilowatt hour, and today is rapidly approaching $100 a kilowatt hour. And all of this has largely been driven by demand and industrialization of these technologies. History as a guide tells us to focus on what we have accomplished and identify ways to accelerate the growth of these climate tech companies. Like many of you, I believe the scientists and engineers have done their part. The technologies that we need are already out there, and you've heard about some of them from this lovely panel. There have been a substantial rise in allocation of climate over the past decade. Investment dollars in 2013 is about $2 billion associated with climate. In 2023, that rose to $30 billion. That's after falling from the big SPAC boom in 2021 and 2022. Unfortunately, and this is important here, that growth has been lopsided. The number of early stage players has grown significantly, and they've grown to support the development of climate tech companies, but there still remains a lack of sufficient capital to scale these businesses. In fact, growth capital has remained wildly unfunded, with just $1 funding available for every $3 demanded. This is concerning when you consider the following. Generally, to jump from development, that's your pilot stage, to deployment, that's your commercial stage, requires about 10 times of capital to execute. So what can we do to fill this funding gap? I agree with you. We need stability on policy. As an investor, a changing policy environment is nothing but uncertainty, and uncertainty means I don't deploy capital. The horizons by which we need the returns, really it's contingent on understanding where the political environment will be. We need to recognize the pools of capital of what we have and find ways of expanding the pools of for-profit dollars through increased collaboration with both governments and nonprofits to buy down the risk to get to where the market actually is. And lastly, on the entrepreneur side, entrepreneurs and their teams need to increase their learning velocity and their capital efficiency. And they need to recognize that failure doesn't necessarily mean a fatality. This would increase the path to successful outcomes and will catalyze the capital formation. So thank you. I look forward to sharing and learning with the rest of you today.
Thank you very much. Now, I have a certain number of people who've already shown interest in speaking. I'm going to start calling each one of them one by one, but in the meantime, if you have a contribution to make, follow Brian's example there and just take your name tag and put it vertical so I can see it. And if you're in the audience, just raise your hand and hopefully I'm looking around enough that you grab my attention. But can I start with Francesco Corvaro, who's the Italian Special Envoy on Climate?
Thank you very much. Francesco has left for another meeting. I will then take over in the comment part. Thank you.
Can we hear from the Polish Undersecretary of State, Milos Motkia?
First of all, I would like to thank the IEA Secretariat for organizing this debate on the extremely important issue. The innovative technologies are unfortunately highly risky investments that require both patient and long-term financing. Therefore, it is necessary for authorities to give a clear message to investors and create regulatory framework for technologies which fulfill the requirements for clean technologies and contribute to climate goals. The support is necessary primarily in phase of development and implementation of the technology. We just can hear at the opening part of the Innovation Forum that 35% of the technologies needed for decarbonization of the economies are still to be developed. It is a real challenge for us to overcome this barrier. The reduction of cost of energy storage is, in our opinion, the most important step on the path to achieve the carbon neutrality until 2050. It will help us enhance the integration of renewable energy sources with the energy systems in effective and secure manner, which is the condition for decarbonization of several sectors of the economy, including transportation sector. The tight supply chains are responsible for high price of critical materials. That is why we should focus on research on energy storage. We need to find cutting-edge technologies which will help us become more independent from the supplies of critical materials and reduce the cost of energy storage. The energy storage is the foundation of clean and innovative economy. Better cooperation for development and environment for transfer of storage technologies is necessary for success of energy transformation. Thank you.
Thank you. Kate Hampton from the Children's Investment Fund Foundation.
Thanks very much. Nice to see everyone. We are really, really pleased to be participating in this conversation. It's very timely following COP28, and I want to commend the IEA for the extraordinary leadership role it has been playing internationally on showing the direction of travel for everyone. I come from a philanthropic institution, and I just wanted to highlight some of the sorts of things that philanthropy can do. We've heard people refer to the need for philanthropy to participate in bringing down the risk of investing. I think it's important to take a broad view. We work, for example, at the different stages of energy transition in different countries around the world. We were one of the very, very early supporters of developing a North Sea strategy in the EU for offshore wind deployment and the transmission implications of that. We've identified gaps such as in Southeast Asia, the lack of pre-project preparation. We cornerstoned the CSEF fund, which is now in its second round to support pre-project prep. And it's not just growth capital that's missing. I would say that pre-project preparation support as well as project equity is really, really in short supply and one of the major bottlenecks in many of the places that we work. For countries in mid-transition, we're doing a lot of work supporting energy transition from a policy perspective, but also from a sort of alignment of financing streams through country platforms, which is very, very tricky work. So many of the solutions that we're identifying are actually coming from the financial sector. We have a really serious issue of debt sustainability, and the fiscal situation of most countries is challenging. It's obviously most acute in low-income countries. But until we stop the net capital outflows from emerging markets and developing economies, we have no hope of solving the climate problem. It is absolutely essential that anyone who cares about energy is laser focused on bringing down the cost of capital for developing countries and finding swift resolution of the debt crisis. There is overcapacity of renewables in China, which is ready to be deployed. The financing has been announced by countries like UAE and Germany and others, so there are pools of capital available, some of which are concessional. We need a really concerted effort to bring all of this together. It is absolutely vital that the people that don't have access to electricity have the opportunity to do so and do so in a green way. Despite the fact that renewables investment has massively increased, most of that has been concentrated in the US and China. Countries do not have those balance sheets. They do not have that level of scale. We have to find a way to standardize, aggregate, and bring down the cost so that more countries can participate in the green transition. And we have to be focused on the misalignment and dysfunction in the financial sector, bringing together public sector, private sector, but also very important structural reforms. Only 2% of European insurer investment, for example, is spent outside the OECD. And that theoretically should be some of the most patient capital in the world. We have a system that is not delivering. We have renewables that is ready to be deployed. We have countries in desperate need of this who are sitting in a debt crisis with money leaving the countries. This is a situation that must not persist, and we must fix this over the next year or two. Philanthropy stands ready to support with technical assistance, with providing many of the solutions. I've been personally engaged with the Bridgetown Initiative and a number of initiatives aimed at global financial architecture reform. We need to bring those conversations together. We can't have a siloed conversation around progressing the energy sector transition without fundamentally tackling these financing barriers. Thank you.
Thank you very much. I wanted to bring in AD Africa, if you want to speak on some of the issues around financing of technology in developing countries, or any other points you want to make.
Thank you very much. I've got 2 points, especially in terms of, as you said, the financing. There's a lot of financing that's happening around renewable energies. But where I come from, I feel like there's still a lot of collaboration and coordination, especially relating to retrofit solution for energy efficiency solutions, because you've got communities that do not have resources or even financial means to switch to these alternative solutions. And if you look at the cost of implementing or using renewable energies, an ordinary citizen or layman, they don't have access to the amount of money that you need to have in order to switch to alternatives. But what is government and the other institutions in terms of financing when it comes to retrofit solutions and also creating enabling environment? Because in most cases, even when there are solutions in the market, the regulatory framework in terms of policies, in terms of warranties, in terms of how do we bring in the private sector to endorse these technologies and be able to roll them out into the market. And I'm interested to find out from Ms. Wang in terms of how they've managed to do it in US in terms of bridging that gap between private sector and government and innovators in terms of adoption of these technologies. Because you said from your point of view, the value of death you've created into becoming opportunities. But in most cases, even when you look into the UNIDO case studies, most of innovations, they really fail at that stage because we lack the support that takes us to the next level as innovators in terms of bringing these technologies to market. The moment you reach demonstration and you approach private sector, sometimes those doors are closed on your face and there is no way you move forward. So what is the best approach or the best model that you've used in US in terms of making sure that this valley of death becomes this mountain of opportunities? Because that's where we all fail. And it takes a lot of investment, and with investors being not particularly keen in terms of risk and the time frame, because now the runway becomes short if you still have to go through all these policies in terms of warranties and product certification. By the time year 3 or year 5, you are out of the market, and sometimes the technologies have changed. So how then do we bridge that gap in terms of moving forward? Because that's where I feel like innovation in terms of financing gap and enabling environment is critical. Thank you very much.
Thank you. I see there are a number of people who want to speak. I want to stick to some of the themes that we've raised here, and James, maybe you want to make some points if they are linked to what was being said. Yes, James, with Africa Climate Ventures.
Thank you. I did want to pick up on on the point and the imperative around cost of capital and beginning to flow resources into unlocking renewable energy potential in the global south. I think Kate has alluded to it. It's in some ways the towering irony of the energy revolution that the continent best endowed with renewable energy potential, 60% of the world's best solar, is also the continent where we talk about energy access as a real challenge. We think about it purely from the level of households and how we get them energy access, but we should be thinking about it in terms of energy-intensive applications globally. And as we're thinking about how we decarbonize global sectors, one of the ways we solve the question of bankability of energy in Africa is stop thinking about it as being purely about getting energy to African consumers and being about how do we channel African energy to global industrial use cases. Not by moving the energy, renewable energy is fiendishly hard to move, but by shifting some of the use cases. So how are we thinking about energy-intensive processes that can move, as well as new energy-intensive technologies, things like, where we put our world's, the global data center fleet, things like, closer to home, all of those raw minerals that undergo energy-intensive processing outside of Africa, leaving behind untapped renewable energy in Africa. And things like new technologies such as direct air capture or the green hydrogen ecosystem, all of which will need large amounts of renewable energy headroom. If we're thinking about these areas where there is global demand, and asking where is it that you can most efficiently get green electrons, then suddenly some of these energy projects become bankable, not because the credit rating of individual African countries has shifted, but because these particular projects are indeed more globally bankable rather than locally bankable. So that's one lens that we may want to look at and think about Africa a little bit differently in the whole energy system that we were thinking about.
That's a very important point. I think we underappreciate how much minerals are going to be needed, and they are going to come from places that are usually exploited for those resources. Instead of that, you could have the raw material then processed and add the value addition step in those regions where also they're endowed with clean energy. So it's a very important point to make. I wanted to bring in Portugal, and perhaps if there's one thing beyond the remarks you want to make, if you could address some of the questions that were raised around what are examples of things that have worked in your region that have allowed technologies to come to scale, things that Sandra was raising as a question.
Okay. Thank you for this opportunity. Congratulations to IEA for the 50th anniversary. I would like to tackle, I come from the National Laboratory of Energy and Geology in Portugal. I would like to tackle something that is very important for the acceleration of renewable investments, which is licensing and permitting. Besides its stability of regulations and the financing access, licensing and permitting is a huge bottleneck. And in our country, my institute mapped our country according to our geoportal, because we are also the Geological Survey of Portugal, and we identified areas less sensitive to environment and social impacts. Geo-reference in all country, and it aims to give an answer to the so-called go-to areas from the European Commission. This was innovative, but I think it's very difficult to be adopted. Maybe we need to convince better the stakeholders. It has also to do with Critical Raw Materials Act, because it allows the target from the European Commission of 10% of exploitation inside Europe. So I think this was a good practice I would like to share.
Thank you. There are a number of interventions from companies that I see. There's Google, Microsoft, and IEA Corporation. Do you want to just go in that order and keep it brief? Thank you.
Thank you for the opportunity, and thank you to the IEA for the invitation. My name is Maud, I represent Google today, and I would call us as a large industrial energy user. For context, we have a net zero objective by 2030, and electrons are already at the forefront of this strategy for us. Throughout our data centers, we're aiming to reach 24/7 carbon-free energy for data centers. What this means is we are looking for local clean energy to operate our data centers by 2030 in all of the regions where we are operating. The reason for that was really for us twofold. One is to reconnect our approach from a corporate ESG perspective and really carbon-focused approach with the reality of what it takes to operate and grow a business sustainably on a local fashion. What we understand is that each grid is going to take a very specific approach for deep decarbonization, and how do we engage with those local stakeholders and pick the local technologies to help us move toward these clean grids and electrification. So as a large energy buyers, we've been looking at advanced clean energy technologies for a couple of years now. We believe that those are fundamental for us, all of us energy users, to reach 24/7 carbon-free energy. Specifically, we're looking for electricity technologies, such as what we call clean, firm, dispatchable baseload generation, but also what we call clean peakers, so long-duration energy storage or green hydrogen as a vector for electricity. Couple of learnings. Our focus has been primarily on accelerating the cost curves and the deployment curves of those new technologies between now and 2030, from what we call first of a kind to nth of a kind. And as a large energy off-taker, how can we be one of the first commercial users for those technologies? I would say the key lessons for us over the past few years is that this is less about the technology itself. There's a lot of great technologies being developed today, and really the hurdles has been on the commercialization side and all of the complexity that we've seen on moving from technology to projects to actual contracting between all of the stakeholders. So very quickly, I wanted to share specifically 3 pain points, but also opportunities that I see for the value chain. The first one for us is really around monetization for those technologies. Too many times we see that those technologies can provide very useful services at the grid and system level. However, the local market designs do not have the right products to help us or to help the utilities or the technology providers properly monetize those services. Each market is very different, depending, we're working on regulated utility territories, but also deregulated markets. And we see that it's still hard for us to modernize a lot of those products and services and really bring the value to the table that those technologies are truly delivering to the grids, and therefore improving the business models for those technologies. The second aspect for us is around financing. I think a couple of folks have already touched on that. What we see between first of a kind and nth of a kind is generally those projects tend to be too big for VC funding, but too small for traditional infrastructure investors. So you have this gap. And this gap is either going to be a hurdle for us to just find those projects in the timeline where we need them, or it's going to create a high cost of capital that then translate into a higher green premium for us. So how can we create room for more catalytic infrastructure investment and really fill that gap? And the last opportunity from our perspective is it remains a very complex value chain. As an energy user, we are at the far end of this value chain. It starts with the technology companies, but you also need project development, permitting, siting, interconnection. You need EPC. A lot of those technologies are being built for the first time. Where do you find the skill sets and the expertise to build those projects in a cost-efficient manner? And then finally, again, you're going to have a utility or an energy providers in between. So there's a lot of complexity, again, on the structuring and the contracts back-to-back. Who bears what risk? How do we create the transparency from a cost-risk perspective, but also a performance perspective? And as, again, an energy users, we've been keen on engaging more and more deeper into this value chain, but I think there's a lot of opportunity for contract standardization across all of the stakeholders.
Thank you. One follow-up quickly. When you talk about market design for monetization, are you talking about having your energy resource, so say you build a solar plus storage resource, not just be decarbonizing your data center, but if it's excess availability, go back to the grid? And is that a challenge? Has that been done anywhere?
So it's a great question. I think this is less around the behind the meter, front of the meter, or feeding. This is really around what are the values that those assets are providing and how are they being compensated for those services. So more specific examples is around capacity value. I think today a lot of the markets are looking at what should be the proper design to compensate those assets on capacity. How do you value capacity from different types of battery technologies, for instance? Today we have a couple of markets where we see that capacity value is almost attached to the technology itself, and it should be more around the standard specifications or capabilities of the technology, or more technology agnostic products, if that makes sense. And then the last piece is, I think, Europe is a highly deregulated market, but again, we're still operating in more regulated, vertically integrated utility territories. Those are where we see more like rate structures, and I think those rate structures are still evolving and need to help us, again, compensate for capacity, supply. So again, we're looking at carbon and decarbonizations, but trying to reconnect with supply and capacity value on top of that and balancing.
Thank you. Microsoft?
Thank you very much. Thank you very much to the IEA for welcoming us today. As it was recalled this morning during the high-level remarks, AI and machine learning technologies have a key role to play in the current debate. AI can help to expedite integration of renewables. It can enhance nuclear fusion research. It can help us to develop energy storage solutions. It can also, as it was recalled by the Executive Director Birol, enhance grid management. And in general, as the infrastructure needed to support AI models is expanding, we need more data centers, and electricity is a key topic in this evolution. To access the carbon-free energy on a global basis, it has become an absolute point for the development of our own business. And the data centers that power our global cloud services depend on having a reliable, consistent, flexible, and resilient supply of electricity in every country where we operate. History suggests that innovation can curb demand. Between 2010 and 2020, the global data center workloads have multiplied by 10, while data center electricity consumption only increased by 10%. So we're confident that innovation can curb demand. But as it was mentioned in the previous panel, trust is actually the indispensable basis to use these kind of technologies. And as governments, regulators, business leaders, civil society leaders, there is a key initiative to be launched to ensure alignment of AI technology with sustainable outcomes and mitigate resource impact. And we thank the OECD and the IEA for its current work on it.
Thank you. Sticking to AI, which is a hot topic both for what it brings, but also on the energy demand. Can I get Devashish to speak about AI and how clean energy can be a solution for what is going to be a very growing demand for electricity?
Hopefully you can hear me. Actually, building on our colleague from Microsoft, AI is critical actually in basically predicting, optimizing, controlling, and dispatching how renewable energy is used in electricity grids, because no human operators could have their eyes all over the grids watching the wind blow and the sunshine and trying to inject the renewable energy in a timely manner. So we actually made an announcement. We're based in Canada, Canadian startup basically trying to transform how renewable energy is used in grids worldwide. We actually made an announcement on last week on some of the work in Eastern Canada to build a completely wind, solar, battery, connected load, with diesel backup and grid connection, but completely renewable energy system. And it's a blueprint on the ground for what can be done globally. One thing I wanted to add, building on our colleagues from ARPA, the universities come up with the innovation. So we started our company about 7 or 8 years ago, noting all the innovation that was coming out of the universities. Then in the gap between the universities and the multinationals, the conveyor belts to make that happen are startup organizations, such as ours and many others. I would note that 7 of my competitors in software for electrification raised cumulatively $260 million of capital and have gone out of business on down rounds on acqui-hires, in effect, by multinationals. Our colleagues from Africa pointed out kind of like the gap between that innovation and when you can actually fully commercialize. And the capital markets, meaning the VCs, have a different timeline on how we turn these things around. And we all can't afford to go out of business because of that gap between the government funding and the capital markets. In the US market, you're best poised between your government and your VC industry. We're lucky in Canada, but I'm sure colleagues in Sri Lanka or India or wherever would have more difficult access to capital, but they would have brain power and lots of smart people with computers who can do it. So what I ask the community in general is how we can work collaboratively between policy, government, and venture capitalists to help us bridge this critical gap.
Thank you. I'm going to bring an intervention from outside the table so that others are encouraged to raise their hands as well. But there's a question, contribution here.
Hi, good afternoon. I want to kind of maybe bring a...
Introduce yourself.
Sorry, I'm Ambud Sagar. I'm a professor of public policy at the Indian Institute of Technology in Delhi, in India. I want to kind of try to introduce a somewhat different layer into the conversation, building on some of the points that have been made earlier, but I've been sitting here staring at that slogan that says, building a secure, affordable, and clean energy future for all. For all. IEA projections show that under business as usual, we will still have approximately 775 million people across the world who won't have access to electric power. More than 2 billion who will not have access to clean cooking energy. I think a lot of the conversations in this arena are dominated by climate change, and it's absolutely important. I think nobody can deny the importance of addressing the climate challenge. It's important for everybody across the board. But I think in that and a very understandable push for focusing on climate change, I think some other things like energy access get lost. Kate mentioned energy access. James talked about, I think, a very important dimension that as we're thinking about clean energy future for all, and it's something that has become very apparent in the climate arena, you cannot ignore developmental imperatives. And I think the question really becomes, and I think maybe that's something to think about in this venue, given the fact that there's a renewable energy revolution that's going on, and a storage revolution that's happening, how do we actually piggyback on that in order to also address the energy challenges of folks who don't have access today, who are projected not to have access for the next 10 years and beyond? So in other words, I think if we want to really be true to that slogan there, I think we must also, in these conversations, think about that piece of the story. And I think it's actually the right time to think about that because, as I've just said, the clean energy revolution really offers a very different set of opportunities to allow us to address energy access in a different way, but it's not going to happen under business as usual. And therefore, I think that must certainly be part of this conversation. Thank you.
Yeah, it's a good intervention. When we talk about these issues, read any international document, the mention of just transition does not go by, and just as a lens of ensuring that everybody has access even as we decarbonize is crucial. Now, there are a number of people who want to speak. We only have about half an hour, so I'll just urge all of you to keep your remarks short so we can get more come through. I can't quite read your name there, but if you want to introduce yourself and speak, thank you.
Thank you for bringing me in. I'm Smita Rakesh. I'm partner at Social Alpha India. We are an Indian organization that runs a network of incubators, targeted accelerators, and an investment engine which brings in grant and equity investments for very early stage product-based solutions and startups. Now, we were talking about financing earlier and some great interventions that I briefly want to touch upon. We said how, we spoke about earlier how we see funding in clean tech is not just less, but is also diminishing. But there are three more dimensions of it that I would like to touch upon, and one Professor Ambud Sagar just briefly touched upon just now. One is the bias that we have towards service and platform-based solutions than product-based solutions, just because of the deep tech nature of it. And I'm not talking about the R&D funding that goes towards it, but also the early stage venture funding that is needed to make sure there are enterprises that take those products from lab to market and then for large-scale deployment. What ends up happening is that we're looking at more of, the numbers that we see are heavily skewed towards aggregator platforms and solutions which have impact, but ignore a lot of game-changing solutions, whether in energy storage or other deep tech areas. The second bias is with respect to the deployment use case. One missing piece in the decarbonization story, particularly in developing countries, is that of micro, small, and medium enterprises. In a country like India, that consumes roughly about half of India's industrial energy. And that is a big problem, not just from a point of view of energy needs and climate, but also inclusion, as we just spoke about, because this also is the enterprise segment dominated by the most marginalized communities from an income as well as social complexity point of view. The third issue is the dichotomous and siloed approach towards financing of what is the energy access solutions that we just spoke about, which is assumed to be supported primarily through philanthropic funding, whereas the more industrially focused solutions are looked at from a venture and commercial capital point of view. Now, this ideally could have gone hand in hand, but it doesn't, and that's where it impairs the just energy transition agenda. So these are the three dimensions of already scarce funding going towards clean energy solutions, but also being heavily skewed and biased in ensuring that we're looking at inclusion for all. Thank you.
Thank you. Waiting for quite some time, so please.
Thanks very much. I'd just like to talk about the benefits of combining two important types of technology and getting a synergistic boost in terms of delivering on climate change. That's combining bioenergy, particularly aimed at the hard-to-abate sectors and hydrogen, with aggressive carbon capture and storage. So the IEA sees bioenergy as delivering about 18% of net zero energy. So that's a big, big chunk. But with aggressive carbon capture, there's another 10% that's available on top of that to make a really, really big contribution. That would be sort of from a combination of supplying energy, biogenic CO2 for hydrogen-based e-fuels, and biogenic CO2 for carbon dioxide reduction. And then just to close quickly, the key to getting that type of technology moving forward and to getting the market pull for it is to have mandates and targets linked to carbon reductions. So following the model of the GHG quota that Germany has, the low carbon fuel standard in California, or even the IRA hydrogen targets. But make sure that targets are linked to carbon reductions like we want, rather than simply the volume of fuel that people get.
Yeah, it's an important point. Even as governments need to be part and crucial to technology development, they need to be supporting innovation and not choosing winners in this landscape. I'm going to stick with technology, helio storage, if you want to speak.
So I'm going to talk just very briefly about, we are helio storage, a seasonal thermal energy storage startup, and we are at that point where we have developed and deployed technology and we're ready to jump across the valley of death. But we are coming up against some very real, and I'm sure for many startups, real issues with regards to what funding is available for companies that want to buy technology to decarbonize heating. So a very real issue that we've had recently is with a company that was basically comparing us against a heat pump only system. We provide the same energy with the same heating with 25% of the electrical energy. There is funding available for heat pump only and not for our type of technology, so not including storage. When speaking with a legislator in Brussels, I have been told that what we need to do is to put lobbyists on the ground in Brussels, and it's really not a viable option for a company with less than 10 employees. So how then do we jump across that valley of death? That's my question.
Maybe we can go to your neighbor. NH2 Green Steel is, as a startup in Europe, actually raising money and scaling up and has maybe jumped the valley of death.
Yes, I think that equally important to having the right innovations when it comes to technology, it is about having the right innovations when it comes to business models and the funding scheme. Getting 6.5 billion euros, as we successfully did, could not have been possible unless we were thinking partnership and collaboration across the whole entire value chain. And that is with different type of industries, that is with different type of customers, that is also with policymakers, to get it all going. We in the investments have brought in customers like BMW, Mercedes, and Porsche that was willing to take a bet on us and actually sign take-or-pay contracts that never been signed before in the steel industry for 5 to 7 years long contracts. That is very innovative. We have had collaborations between nations where a lot of our technology come from Germany, and a lot of our customers comes from Germany. The ECA from Julia Hermes has been absolutely critical for us to actually get in place. So financial institutions in order to get it there, and the EIB also in Europe on the debt side. I think as we talk about these partnerships across the value chain, I think also in terms of how we worked with policymakers and authorities when it comes to the permit was absolutely crucial, where we learned a lot from the authorities in terms of technology choices. Before the permit was turned in, every single word had been actually written or actually been read by the policymakers, which eliminated a lot of confusion and made the process smooth. Maybe one of the most surprising partnerships that we have is actually within the steel industry, where the oldest steel maker in Sweden, Ovako, and the youngest steel maker in Sweden that hasn't even produced anything yet, H2GS, has gone together in order to have a really smooth production flow of hydrogen, but also introducing AI into steel making, which will really make sure that some of that gut feeling when it comes to making the right type of steel could have informed decision making instead for the future and save a lot of money. So putting this all together, I think that tying a lot of the conversations that has happened now in this room, I think it is absolutely crucial when we talk about nation collaborations and the global effort to actually make this green transition, that we do it in a sustainable way, that we are identifying those places where part of the value chain of certain products that should be made are done in the most sustainable locations, where you can get access to green electrons, or where in the future you will be able to get access of the green electrons in a cheap way. But it's not only, and I would like to echo that from some of the discussions that have happened, it's not only that the energy needs to be actually produced in those emerging markets, it's also that value creation needs to stay there. So for example, in steel making, we have heard it before, but the most energy intense part is the iron making, not the steel making. So why not actually making the iron and break up the supply chain, make the iron and ship it into the steel industry where it's needed across the world? So innovative ways of actually making both in terms of the business model, in the financing, and also how we actually think about where the products should be made.
Thank you. Sticking to Europe and technology, Elena.
Yes. Thank you, Elena from IEA Energy.
You'll have to pull the mic.
Thank you. Elena Bow from EIT Energy, one of your investors in H2 Green Steel. I just wanted to comment three things. First one is that energy and energy security comes with also industrial policy, and I think that this has been a latest change. And that has to do exactly with the topic of scalability. Technology is already here, but we need to make it scalable and have such an impact. One of the big examples, or the good examples that we have in Europe has been, in order both concepts to go together, has been the European Battery Alliance. I would like to mention it because you were talking about the supply chains, and I think that that was a concept that the European Battery Alliance started in the year 2017. And if you remember there was just 1 gigafactory planned to be in Europe. Today, the number of projects have multiplied. And going deeper about the reflection, because Energy received the mandate from the European Commission to lead this kind of industrial part of the European Battery Alliance, what are the thinkings about how it has been a success? The first thing is changing the rhetorics. The rhetorics had to do with a market opportunity, not a threat, not something sad or horrible. It was a market opportunity of identifying a market of 250 billion per year since the year 2025. So that was what created a kind of market pooling, kind of enthusiasm. Okay, what is the opportunity? What these people are talking about? Secondly, it has to do with all the, to group together all the supply chain. I think that this is super relevant. So we were talking from minerals, raw materials, till recycling, okay? And putting all together in the same table, the public and the private sector. And I think that that was the first time that we were able to see this kind of dynamics. The other thing is that in that European Battery Alliance, it was incumbents and it was newcomers. And these newcomers, like H2 Green Steel or companies like Northvolt or whatever, I mean, innovators that were bringing these kind of new technologies. And the other aspect is that that was going to create jobs. And here it is where the topic about skills is totally a must. I mean, a strategic value change is as strong as the weakest of their step. And skills, today, at least in Europe, is something that is a great challenge. And then finally, in Europe, we have created a regulation that it is coherent with that spirit of sustainability. I'm talking, for example, the battery passport. So I think that there is an alignment of many different aspects, and that is why I wanted to share with you that this is one of the benchmarks in terms of collaboration, because it involves joining forces under a same more or less plan. And the last point is that in this journey, as you mentioned, there is a gap in terms of finance. And the finance has to do about, well, let's call it tough tech and in industrial startups. Why? Because there is still risk. They are not bankable, but they need a lot of money. And that is where there is a question mark. In your case, in H2 Green Steel is an example because it is a mixture of debt and private capital in a very early stage. And we need this kind of schemes. And this is something that for that, okay, we have to look also to the public money because it is true that many schemes, they are just looking for technical innovation. And here there is more innovation than not only technical. But the other part has to do with, let's do the talking. Banks want green finance, start taking risk. And that is your point about willingness to take a bit of risk. So thank you very much.
Thank you. We do have a hard stop at 12:30. I'm going to actually finish 5 minutes early because you all have an opportunity to go into breakout sessions from 12:30 onwards. So we still have, I see, 4 interventions available. If you can keep it to 2-3 minutes max. Italy.
Thank you very much. I would like to come back to 2-3 points. The first one being the priority sectors for innovation. Thanks also to the excellent work of the IEA, we had very, very strong progress in terms of renewables, and in terms of use of energy also in giving the possibility of declining prices. However, I think there is still a very strong priority to be achieved, is the importance of networks and of digitalization of the networks and of the integration of all the different sources thanks to the important role of networks and of their digitalization. Italy sponsors very much also a project called 3DEN dedicated to the digitalization of networks. Then one thing that has worked well and one thing that probably needs additional work. In Italy, I think that one aspect that has allowed to integrate innovation into the system, the energy system, is related to regulation. The Italian energy regulator is adopting an output-based regulation, fostering operators to integrate innovation into the network. This has worked very, very well in terms of advanced metering, hosting capacity of networks, electric vehicle integration, storage, and so on. On the other hand, I think that from the things that need to be better targeted, why not also in the IEA framework, is the aspect of social license and adoption. I think this is something that is already in the target, but that needs to be further investigated, and scaling up and replication. I think these are aspects that really need to be better addressed also in the framework of the IEA. Thank you.
Thank you. There are three more left. Fizile, again, keep it brief if possible.
Hi, I hope I'm audible. One of the things that we mentioned earlier, and I'm sure I'm not uncertain that any other startup could relate, is that early stage financing is a labyrinth where it's like you're riding a unicycle and you're blindfolded and you're trying to solve a Rubik's Cube at the same time. I don't understand, and I'm not uncertain why it's also been designed like this. Sometimes things are sector agnostic, but they're not really the case. And even when you try to nudge the private sector, it will tell you to go nudge the public sector. So there's this uncertainty with funding your actual idea, which is meant to change the world. Think of it like Iron Man when he was trapped in that cave in the desert, eventually built this arc reactor and flew himself out. So here's what I'm going to be sharing, some of my experiences, and hopefully I could get some shared knowledge and tips after this session. Africa, for one, is something where we've started seeing a lot of intra-country collaborations, is maybe more of what we need across continents as well. I think it is happening, but it's also, it's like a posse with a secret service with secret handshakes, and not everyone has access to it. And I hope that there's something that could come out of this, where if we're trying to create sustainable and simplified value chains or supply chain systems with raw materials, for one, it should be something that's being made more open for everybody. Now, currently at Scooter, we found ourselves at a very fortunate position where both the public and private sectors, are willing to cooperate with us after 8 years of blood, sweat, and gears. And what we've managed to do is now create a combined MOU where we're going to be exploring battery manufacturing and research for both stationary and mobile, which kind of makes sense, because what Africa hasn't done for itself is having the beneficiation process of this, and it becomes so much important to have these types of conversations and to sponsor such ventures or endeavors where it makes the playing field more fair and more competitive from a pricing strategy perspective. So I'm hoping that I can have conversations with like-minded individuals. Just one more. We've also found ourselves as Green Scooter having the first partnership agreement of its kind, where we've managed to source about 300,000 worth of offtake agreements for our electric passenger/commercial vehicle. Now, within the banking space, what we find is that they want to find banking finances offtake agreements, but now it's also based on what's sitting on your balance sheet, and also does it kind of make sense? When the first electric vehicle was made, and I think it was about 1834, there was no offtake agreement. When Ford grew into what it became today, there were no offtake agreements. But financing becomes this bureaucratic flag that is waved only and ever when nobody gets it or gets what's taking place. The second part is we found ourselves having a conversation where and an agreement where we'll be redeveloping 22,000 stretch of road in South Africa in partnership with the national South African National Roads Agency. And what we hope to see, which is how Europe and the West has seen itself being developed, is see South Africa and Africa being developed in the same way. But then again, the question is who's going to fund such projects. So we hope that more banks or people with nice sizable kitties will be able to disclose to us within this room or outside how financing can be more accessible for everyone, whether like me or like you. Thank you.
Thank you. Just last two and only 3 minutes on the clock. There's Evelyn, and I can't quite read the first name there, but if you want to go one by one. So Evelyn first, and then...
Thank you very much, and I'm really happy to be here today representing really a seed stage company at that kind of gap stage funding that we talked about. So my name is Evelyn. I'm the CEO and co-founder of a company called Evercloak. We are a material innovation company with a mission to cool buildings without further warming the planet, so refrigerant-free cooling. And I wanted to highlight today, one of the questions was, what's an impactful approach to policy and partnerships that should be replicated in more countries? So we've been successful in 2 challenge opportunities that the Government of Canada have put into place through National Resources Canada. One is called Women in Clean Tech, and so their mission was to get more women into clean tech. And it was a funding program over 3 years that enabled 6 women from across Canada to start companies from a very early stage technology. And I think I haven't seen a program like this before, where the funding was included, a stipend was included, and I think that was one of the most important pieces to really enable me as an entrepreneur to de-risk that financial risk. And there's so many entrepreneurs that don't have the ability to take their technology to market because of that early financial risk. And so enabling that type of funding structure was a really, for me at least, brought me out of the industry sector and into entrepreneurship for myself and my family. And the other program was a partnership with Breakthrough Energy Ventures as well, so Breakthrough Energy Solutions. And so kind of combining these type of programs to build our technology up and get us to the stage we're at was really critical. And I wanted just to say how appreciative I was, and that's a great program. And then I wanted to echo several other comments here on just speed to market and speed for policy, speed for contracts, speed for regulations. All that's going to be really important to help us grow bigger, faster, and get to market and change the world.
Thank you.
Hi, thank you very much. Vaitea, one of the co-founders of Enapter. We are an electrolyzer manufacturer. We've delivered more than 4,000 units out there, and we're focusing on AEM technology. And I just wanted to raise a few points in terms of the question, well, how do we actually scale up? How do we get to that next level? And when we think about, well, how do we even start by reducing cost of green hydrogen? As an electrolyzer manufacturer, it's about producing our systems and producing them at scale, and that means having factories that are fully utilized, and that means that we need a solid policy framework in order for our factories to run and for the cost of electrolyzers to drop. And this is an entire ecosystem effort. I mean, there's a whole supply chain behind green hydrogen, from cooling components, but also to compressors, et cetera. And we need to move this forward. And as an OEM, we ensure good quality and performance. However, there's only so much that we can do. When we see that we have 1.6 billion in our pipeline and as in demand, we cannot actually fulfill this demand on our own. And seeing that there are many government officials here, I couldn't resist but also talk about these de-risking mechanisms that we also need the public sector to get involved in, and that relies on governments, for example, to provide government guarantees, whether that is in the form of loans, because this will help attract private investments and reduce the risk for other lenders, and also bank guarantees will also move these projects forward. So as we've mentioned, we need a change of mindset and to stack different sources of capital.
I missed one, Anne from Breakthrough.
Yeah, thank you so much. Great to be here. So I offer my remarks from Breakthrough Energy. We essentially bring innovations to market faster, but also from my past life when I actually worked in public policy. And so it's great to be speaking to so many policymakers in the room. And I have to say you have a lot of sympathy, because I wonder what you make out of everything that you heard today and how one would actually operationalize this. So I want to give just a few remarks on maybe how we can do better in operationalizing. And for that, the first thing is I think we need new metrics. And here I'm also looking in more real-time metrics, because so much in public policy is about goals in 10 or 20 years, right? So in terms of real-time metrics, we need to actually measure final investment decisions. A lot of projects are announced, but they never see the light of day, right? We need to actually measure, is there demand? Is a market developing, right? Thirdly, is the green premium decreasing? Do costs come down? If the costs don't come down, it's not going to work, right? At the end of the day, and this is what I hear from all of the entrepreneurs around the table, this is about creating a business model for them, right? Unless you start to make money, you cannot commercialize. It just won't work. And this is the policymakers' challenge. How do you really do this? For that, I need to say, for starters, please stop or at least reduce the subsidies for fossil energy. I'm surprised this hasn't come up yet, but between 2021 and 2022, the support measures for fossil energy have skyrocketed. They essentially doubled from 769 billion in 2021 to more than 1.4 trillion in 2022. How do we expect these guys to compete if those that are already in the system are privileged to that extent? So please think about this, right? We need to create a more level playing field here. The other thing I will say, and this has already come up, is we need essentially to make the energy, reduce the cost of the energy transition. A lot of what we have done has actually increased the cost, right? But we can decrease it. More standardization, more aligned regulations, public guarantees. It was just mentioned. For public guarantees, you can unleash investment without actually having to pay anything. There is so much that governments can do to bring down the cost of the energy transition. Please prioritize that. The last thing I would say, absolutely critical, infrastructure. You guys are in charge of infrastructure. That's not the companies, right? And just, like we have roads and bridges, the new infrastructure is the grids, it's cables, it's charging infrastructure. You need to do this, right? And fast, because a lot of these technologies cannot get off the ground unless the infrastructure is upgraded to this clean energy system. So please keep this in mind, and thank you for giving me an opportunity to share this.
Well, thank you for that final intervention. It was wonderful. I have been energized by the conversation here. As Anne said, there are so many things we've talked about. Not all of them are going to be resolved here, but it shows what is important to the audience, and that's what's going to feed into the ministerial. So please thank all the people who spoke. A round of applause. Now, logistically, a few things. There are 3 breakout sessions that are happening. One looking at innovation in emerging markets in breakout room 1, industrial heat in breakout room 2, and successful demonstration in breakout room 3. They're all across the aisle. And have fun. Everybody's up.